we're the second part of Boss of the Sock here. So let me find it. I'm losing my mind. Projects. There we are, Boss of the Sock. So, before, let me just get this open. All right, I'll use the second one. Doesn't matter, they should both work. Student 1. They're both a little messed up as of a few days ago, but they're still working pretty well. Students are slowly destroying them, as students do. You go to search and reporting. All right. And so we should see about 1 million events. There we are. Okay, we do have about 1 million events. So if I go to look at the HTTP events, all right, here's the HTTP events, and if I sample and search over all time, by the way, I had a student using this all time. This all time is a snare and a delusion. This is looking for right now, real time, which is not what you use this, you won't find anything. You got to use this all time. Anyway, now I'll see some HTTP events, and if I want to find the ones with the vulnerability scanner, since I happen to remember the name, that would be a good way to do it. Acunetics. The ones with that word in it will be from the vulnerability scanner. All right, so there they are, and I'd rather see this in lists than table. And so this is a request, and down here, there, user agent Acunetics product. So this is clearly from the person who scanned it. So now I can find the all important information here. I think I've got it somewhere up here. There we are. So it's the Acunetics scanner. The web server is this 192 ending in 70, and the attacker is this 40 ending in 42. All right. And so then to find the traffic going backwards, we want to take the web server's IP and find web requests coming from that, which you were just talking about in the lecture. This is what you should never allow. You should never allow a server to be a client. So if I put that IP address here, and I get rid of the Acunetics, then I will see traffic that went backwards through the network. And I'll get rid of the sampling. There should be 9 events. Only 1 event. Sampling still on. Okay. No sampling. All right. There we are. So these are the events that went backwards through the network. And those is the event that the bad guy used to hack the network. And this request here is them downloading an image. That's what all this junk is, binary image data coming through. And down here is the name of the image, getting Poison Ivy is coming for you, batman.jpg. And here is the domain name of the malicious server hosting that image. So that's this part of the attack. Now, the point of this attack, this was not the most important attack. This is the attack you will notice when they defaced the web page by putting an image on it. You notice that, but then you got to figure out how they did this. So if you go here, that stuff I just did was the first several flags, and you need that to proceed to the next bit. So you got the attacker IP, the web server, defacement file name, and the domain name, and the scanner name. That was part 1. Now for part 2, we want to find the IP address used to host the defacement file, and we can get that from this request we've got right here. This is the request that downloaded the defacement file. So the destination address of this request is going to be that. So source IP, this is the web server, source IP, and destination IP should be up here. There it is. So this 2322 address is the server used to host the defacement file, and there it is. So the attacker is in control of 2 devices so far. This one they used to do scanning, and this one they used to host their malicious image. So those are 2 things. So any of our computers sending traffic to them might reasonably be expected to be part of the attack. All right, now that we got that, now we're going to find the domain name, and this is something to know. If you have a known malicious IP address, you can just Google it. So here we have this address, that 23 address. So if a bad guy has control of a server, they will use it to host malware for an attack, and they'll probably use it again to host malware for another attack. So if you look at the DNS history, which are what domain names have previously pointed to this IP address, you'll typically find a bunch of them. 12 records. Wayne Corp. And here's the one, poisonivy.com, with ones and zeros. That's the LeetSpeak domain. So this is used, that's what the flag is, finding a domain name in LeetSpeak. But this is threat intelligence. A bunch of companies do archive what malicious servers are on the internet, what they've been doing, and that often helps you understand your attacks. So now we want to find the brute force attack. The way the person originally got in is just the way they got into Microsoft recently. They just tried a list of passwords against the portal until they got in. So we want to find the brute force attack. So we're going to do HTTP events using the post method. So here we got HTTP events, and there's an HTTP method, which is typically post, get, or put. And so I want post method, so I'll click this just to get the format right, and then I'll change this to post. And then I'm going to not restrict it to coming from this IP address. There's all the HTTP posts in the data. So this will be anything that sends data up, such as logins, and probably other things also. So I've done that. Now I want to exclude the ones from the vulnerability scanner, because the vulnerability scanner sends a lot of posts trying to find bad things. So that's not Acunetics. Not should turn orange, but somehow the colors have been turned off on this server, and I haven't figured out how to turn it back on. I have to restore it from backup. So now we should get about 441 events. All right. Now, if you look down at these events, there is a field called form data. It's the data sent in an HTTP post. And so here's some that don't seem very meaningful, sending some big junk. And so those are the, but if I go, say, to the rare values, stuff at the other end of the list, then here I'm going to see there. Username is admin, username is admin, username is admin. Here's username is admin and password equals Arthur, Big Daddy, Blazer, Fire, and so on. This is the brute force attack. Many attempts to log in with username equals admin. So I'd like to exclude these other events that happen to be posts that don't come from the vuln scanner but still are not what I'm looking for. So this username equals admin looks like something that's always in there. So I'll just put that in as a required field. And then I hopefully can get just the attack and nothing else. So if I look at at the form data now, there's form data. Now it looks like they're all part of the attack. Username is admin, password is Arthur, password is Blazer. Here's some list of common passwords they're going through. So the easiest way to see just the data I want is to do a table of time and form data. So I want just that information and nothing else. Now I can see what's going on. Here's the username is admin, password equals this, password equals that. Now it doesn't put them in time order for some reason, which is annoying. You have to click this to put them in time order. So now you see the attack started at 14:45, and there were multiple guesses per second, like all 5 of these within the same tenth of a second. And if you go to the other end, then eventually the multiple guesses per second stopped, and there was a gap of like 2 minutes, and then it came in again. So this is what happened. They ran an automated scanner trying many guesses per second until it finished. Then it will report, I found the password, here it is. Then a couple of minutes later, there was a manual login of the attacker using that password, and then they could upload malware and hack the server. And so you can see that here, and you can also see it if you go back and look at the user agent. The user agent identifies the source of web traffic, like what browser you're using. And in this case, there were 412 events coming from a Python script and 1 coming from a browser. So the Python script is the brute force attack trying hundreds of passwords until they get in. This is the person manually logging in a couple minutes later now that the password has been found. So that gives you several flags here, like they ask you what was the first brute force password, what was the correct password, what was the time interval between the correct password and the compromised login, what was the total number of passwords they tried. All those you can find there. And the only other thing remaining is the executable file name. After they got the password, to get to the administration panel, they uploaded a malicious file there, and we've already done this, find post methods, excluding the vulnerability scanner. We just have to look for EXEs. So I got post methods, not the vulnerability scanner. If I just looked for .exe, then there's only 2 events, and they're going to have the exe. Now, I could hunt through it looking for it, but it's a lot easier to use the browser search engine and search for .exe and highlight it. And now I can use this to move around. There we are. There's the file name of the thing that was uploaded, 3791.exe. And there it is again, another request. So this is what you do. You go to threat post where they have a list of known attacks. You run a vuln scanner, and it says it has this vuln. Then you go and get the known exploit for that vuln, and it's just a number.exe, and off you go. This is how relatively pedestrian, not terribly advanced hackers work. They just use standard tools and standard scripts. And that's what these guys did. So anyway, it's pretty nice. You can see exactly what happened to the brute force attack, what time there was, and all that. And that's why I love Splunk. You get lots of useful information, fast and easy. So I'll stop.